Yes. All right. We would arrive at the talk on the coin. SCI33205 M604 Sem. Yes. And forward to the YouTube. Oh, I have to use the by Surapawin. Yes. X forwarded. This one. Okay. We arrive at the story about the talk on the conductor loop, right? Close and so. Okay. All right. Yes. I have to share screen. Please write down on the chat box, in the chat box. And yeah, with number, with your name like this. All right. And if you are waiting for the class in YouTube, you can also type it in the YouTube chat in order to avoid the error, the failure from me. Please capture the screen of your device, okay, and send it to the live group. I didn't open the live group yet.605 ครับรบกวนอธิบายสรุปเป็นภาษาไทยให้อีกทีอ๋อได้ครับ605นะครับโอเคได้yes in this one right in I think I have to share the link M604 right the link to all of you try giving to links into M604 yes this one นะครับผมแชร์ลิงก์ไปด้วยนะครับเพื่อว่าคุณจะได้ดูไลฟ์อัปเดตครับที่เขาเรียกว่าอะไรที่ในไฟล์ของคุณโน้ตครับเผื่อว่าผมเขียนอะไรนะครับ All right, we live here at talk on the connector loop, right? And if there is any messages, let me know. I will where the oh no.
อาจารย์ครับที่อาจารย์แชร์มามันเป็นไฟล์ของอาจารย์ป่ะครับอาจารย์ต้อง export ป่ะครับเพราะว่าอันนี้มันเหมือนแบบเราก็เขียนแบบของอาจารย์ได้ด้วย
export แบบนี้นะครับเขียนได้คุณเขียนได้ด้วยเนาะเอาเชิญเลยครับอยากเขียนให้ผม export เป็น PDF หรือเป็นยังไงดีครับคิดว่า
PDF ก็ได้
หรือว่ายังไงครับได้หมดนะครับเอา PDF แล้วกันนะ nice SCI332 นะครับคุณอยากเขียนอะไรก็เชิญเลยครับ205 M604 today 11.08.2021 this is YouTube live say oh no I should go to another to this account ไปแล้วหรือยังครับนี่นะครับปึ๊บM604 นะครับพยายามใช้เทคโนโลยีให้มากที่สุดกับเท่าที่ผมเป็นนะครับไปเรื่อยๆก็จะพอรู้เรื่องมากขึ้นครับ Okay, we arrive at this story the talk on the connector loop, right? Actually, it's the extension from the force on the conductor line, right? It's only the extended version from that, but as you know, torque is like the moment, right? It's the force, okay, multiplied with the distance apart from the rotating point, right? 20 August 11. It's 40 and 1410. It's M604. Yes, I think we have finished the completely the magnetic force between two conductors, right? In the magnetic force between two conductors is an extension from the FILB. Okay, that's the typical one we have before, right? In right now, the torque on conductor loop is close to realistic situation. Is what you can see in the electric motor. Okay, electric motor is a kind of machine. I have to copy this. Yes. Now starting. All right. Yes. Yeah. The talk on conductor loop is the moment. Okay, it's a kind of moment. It's the force multiplied with the distance. So you can get the quantity which is called torque. Okay, in this. Yep. Let's consider the simplest case. Okay, that's the simplest geometrical shape in กสิดิตเหมือนว่าพิมพ์มาทางนี้ใช่ไหมครับthe simplest geometrical shape you can find, okay, it's the rectangle, but the theory here can be applied to any shape of the connector. Okay, you can arrange the shape of the connector in any way, okay, whether it's circle, it's oval or ellipse, okay, or ellipsoid or something like that. It's also possible, but at the beginning step we are going to consider only the rectangle or rectangular shape, okay. Yeah, and we will see that in the example there is also the case when we have the connector y in the forms of triangle or rectangle, okay, or circle, okay, any kind of shape that we can use, okay. Okay. Yes. ส่วนลิงก์ที่ YouTube ครับคุณไปเลือกเอาดูนะครับมันมี2อันนะครับ Okay, in order to not waste our time, okay, we have here the connector in rectangle form, okay. Let's say the rectangle has two things, all right. The first one has two sides, okay, two different sides. It can also be the square, okay, typical square, and in that case you have the same distance to all four sides, all right. But rectangle has two different sides, okay. It's called A and B, okay, in this case width and length, okay. In yeah, that's the simplest shape you can find it. The area and so on is quite simple to be found, right? Okay. Yeah, and you can have also another possibility to arrange your connector. Well, let's say there is an input. Oh, sorry for that. There is a point where you can let the current flow in through this. I'm not sure I share the screen already or not. ยังไม่ได้แชร์ใช่ไหมครับโอ้ sorry มีคนขอเข้านะครับมีแจ้งกันที่ไลน์เลยนะถ้าเกิดผมมัววุ่นแล้วไม่ได้มองเห็นคุณนะครับ I didn't share the screen right here, okay. พูดอยู่ตั้งนานแต่ว่าไม่ได้แชร์หน้าจอครับ all right, it's already there, right? Okay, I hope that you can see the monitor, the screen from this machine, all right. Yeah, here let's say we have the rectangular shape of the connector loop, okay. In you can let the current flow in this direction, all right. In where else? And the arrow of the returning current is going to be there, okay, but they don't represent this part, okay. For simplicity they just write down the simple rectangle, okay, but there should be input and output so that the current can flow in this square or no rectangle conductor. Okay. Yes, when the current flow in this from this one, okay, from this point, and it's gonna return to this line or like right here. Okay, that's the top view. Okay, we look at this rectangle conductor from the top view, okay, from the top aspect. And if we let the magnetic field, okay, take place, okay, or flow through this conductor, okay, from left to right, okay, with the green arrows here, you can see that there will be some effects. Of course, the most important quantity for us in physics is going to be the force, right? That's the most important thing. Yeah, force is the main interest in physics, right? In yeah, we will determine the force, but the sophisticated term or quantity apart from the torque is apart from the torque is the so-called torque. Okay, torque is, as I told you, torque is like a moment, is the multiplication of the force and the distance you wanna let it be the reference or rotating points. Okay, in with that referencing point, okay, you measure the distance from the rotating one, in or no, the rotating point to the point where you see the force acting on that bar, on that object. All right, and that's the way we have the force or the torque, right? The torque is the extension, okay, the sophisticated one, okay, but it's not too difficult at all for us to understand. All right. Yeah, we go ahead with the next on the next page. This is the side view. Okay, it's the same thing, but we look at it from the different perspective, okay? From the different angle. It's the side view. All right, in yeah, with this one you can see simply that there is force acting on the conductor, but I will tell you later how we could determine the direction of the force. Okay, and that's it, right? Okay, we need to determine the direction of the force. Okay, if we take a look at this, F1 is going to be point here. Okay, it's directed upward. Okay, it's directed out of the lecture notes in this on the monitor or on the screen, right? And the force F number 2 is going to have the cross sign here is pointing down, right? According to this notation, right? So how could we find? How could we determine, or how could we conclude that the force on the left side is pointing upward, and how could the force on the right side is pointing downward from this figure? Okay, you just borrow the idea from the previous topic. It's F equal I and vector L cross vector B, right? That's what you have found before, right? And of course, when we have once we have the current
flowing in this direction, it means our vector L is going to be here, right, in this direction. That's the vector L. And yeah, you have L, right, in this one, pointing in this direction, and you have, of course, the magnetic field here, vector B, like this. Okay, when you curl or turn or rotate your four fingers from L to B, right, from the first vector, the vector number 1 to the vector number 2, all right, you will find that your thumb direction is going to point upwards here. Okay, pointing is going to point out of this plane. Okay, that's why you get the dot symbol here, the force on the left side, which is denoted by the F with subscript number 1. Okay, on the left side is pointing out of the plane. Okay, or if you look at the side view, is pointing upward. โอเคงงไหมครับไม่งงนะทางด้านซ้ายนะครับมันมาจากสิ่งที่คุณเรียนรู้มาก่อนนะครับ ILB นั่นแหละโอเคไหมจะ QVB ILB ใช้มากครับกดมือขวาห้ามลืมนะครับทั้งที่ผมบอกว่าเรียนมาเรื่อยๆห้ามคุณทำมือขวาหายครับใช้มือขวาอย่างงงนะครับโอเคถ้าหมุน3นิ้วไม่เป็นเอาหมุนเป็นง่ายๆสุด4นิ้วนะครับโอเคไหม4นิ้วจากเวกเตอร์ที่1 L ไป B นะครับแล้วคุณก็จะได้ผลลัพธ์มีอะไรเตือนมาหรือเปล่าis there anybody okay someone is gonna join okay hear the lecture anyone else no นะ what happened okay well yeah that's the force that can take place on the left side. What about the force direction on the right side? Of course, we have here the current flow flowing in this direction, right? And it's going to get out this way. Right? It starts from here, right? Yeah. Yeah. But we neglect the small distance here. All right. We neglect the losing area here. Okay, losing coverage of the connector. Okay, we can simply look at this configuration as the perfect square rectangle. All right. Of course, we on the right side we have here vector L. Right. It's vector L because we've borrow the direction of the current and we borrow the length of the L, right, on this side, which is B. Okay, the length of L on this side is B. All right, and the second vector is gonna be vector B, right, magnetic field vector, and of course you have to apply again the FILB formula in order to find the output direction, which is the force here. Okay, let's start to rotate our four fingers. You can start from the first vector L to vector B like this, right? And you will find that when you use your four finger, right, the force is gonna point downward. Okay, pointing into this lecture note, and that's why we get the cross sign, which represent the rear part or the tail of the arrow. Okay, and yeah, that's the force. Okay, on the right side we have the force pointing out of the plane. On the right side we have the force pointing into the plane. And if we take a look at the same figure but from the side view, you can see that you have the force on the right side pointing up and force on the right side pointing down. And this the reason why we have talked on this copper wire. Okay, it's like the bar. Okay, you have the moment. Okay, this is the rotating point. Okay, or reference point. Rotating point. Okay ถ้ามีคำถามอะไรเขียนอยู่ในไฟล์เลยนะครับผมแชร์ให้คุณมากที่สุดนะครับโอเคไหม อาจารย์ครับมันต้องเป็นแบบนี้ครับผมคิดว่าอย่างนี้หรือผมมีคำถามคุณวาดรูปมาในสไลด์อะไรเลยนะครับไม่ต้องเกรงใจผมนะครับขัดจังหวะได้ทุกวินาทีนะครับโอเคไหมเอาที่คุณเข้าใจมากที่สุด alright yeah, this is the reference point or the rotating points in of course you have the let's say this is the center of the clocks and here is the clockwise direction, right? Clockwise okay, clockwise direction, and we are going to have the talk on the clockwise direction, right? Because it's try to keep this conductor rotating, okay? So it's the circular force, okay? It's try to rotate this one, okay? Let's say this is the reference point is fixed and the conductor loop is gonna turn or rotate according to this arrow, okay? Because if the force on the right side is pointing also upward like this, there will be no rotation, okay? It's gonna move upward, okay? But on the left side, it's pointing up. On the right side, it's pointing down. So it's gonna move this conductor in terms of rotation. All right. And yes, the moment on the left side is gonna be the torque, right? Torque is force time distance, right? The clockwise direction. I'm not sure. All right, the torque on the clockwise, because there is only clockwise direction. The first one is F1, right? The magnitude F1 times the distance, and what you may observe is that the distance here is, I don't know. Well, here is A, right? Here is the A. But our referencing point or reference point is gonna be here, half this side, right? Okay, the rotating point is half the width side. So the distance here is gonna be half of that. Okay, is A by 2. Okay, and another side is A by 2 as well, right? And that's why we have here the distance A by 2 as well from the reference rotating point, okay, or reference point, okay, and the distance is A by 2, right? So you have F1 times A by 2, okay, and this is one of the torque that can happen with reference to this point, okay. It's the counterclockwise, okay. Try to rotate this bar in the clockwise direction, but there is another potential or the possibility, okay. Here on the right side you have F2, okay, and is pointing downward, and the distance from the reference point is also A by 2, right? So you can write down here the torque is doesn't include only a single F1, but there is also F2, okay, and the distance is going to be A by 2, right? And if you go into the detail, you will find that F1 and F2 are the same, okay? And F1 and F2 are the same, and let's say F1 and F2 be F, okay, without subscript, and you're gonna see that torque will be F A by 2 plus A and F A by 2, right? And it's gonna be A F, simply like that. All right, it's not too difficult, right? Yeah. We will go into the detail later. What is actually the expression of the F, okay, which is the magnitude of the force for those two forces, okay? And here is the situation when the when the loop or the conductor can stay at any position. Okay, any position means that at any angle. Okay, and what is the angle? The angle that we will say in this topic is the angle between this is the plane, right? The plane of the circular conductor, the rectangle loop or the conductor Y, right? And of course, any plane is gonna have the so-called normal vector. Okay, ก็คือ vector ตั้งฉากกาลนานะครับ okay, normal vector of that plane. Okay, the conductor actually is not a plane. Okay, it's not a smooth surface, but it's made of the the loop of the conductor. But and we imagine that the surface that includes these include the area of the whole conductor is gonna be the plane. Okay, but there is no plane at all. It's only the conductor loop like this. Okay, but we assume that the air and space here, okay, be inside the conductor forms the plane, right? And any plane is gonna have the normal vector, and the typical property of the normal vector is that you have right angle, which is 90 degrees from the plane, okay, the plane surface to that vector. And the angle we will talk about in this topic is the angle between the normal vector of the plane. Okay, it's not the angle of the plane itself with respect to the magnetic field. Okay, it's the normal vector of that plane with respect to or measure comparing to the magnetic field like this. All right, yeah, this is the instant that we can have, right? Because when the conductor starts to rotate, it can have any angle with respect to the magnetic field, and we're gonna see what is the torque at that moment and what is the force at that moment actually. Okay, and this is the result we have taken from the book, and they just say BIA sine theta. We will go into the detail later why we get to BIA sine theta. What is B? B is the magnitude of the magnetic field vector. All right, that's what you get familiar or get used to it, right? It's the magnitude. It's in Tesla, right? The unit for the magnetic field or magnetic flux density is Tesla. And what else? The next thing is I, right? Oh, this is quite simple. Okay, the Oh, I don't understand. Maybe there is an internet problem. All right. เดี๋ยวนะครับขอเสียบหูไว้อีกสักข้างนึงนะครับโอเค all right กลับมาแล้วนะครับไม่มีใครแจ้งผมนะว่ามันหลุดครับ14 I think it's 13:50 right I need to leave you because you should have the break of 20 minutes right okay let's get to the our lecture notes again and I have given all the detail to you FILB right it's I right and L okay L is the length B is the what is the reason why we get B because the length of the vector L is B okay and that's why we get I B okay I small b and capital B of course you know that the capital B means the magnitude of the magnetic field right so it's quite simple in order to get better quality we are going to use only the mobile data right นะครับเพื่อไม่ให้หลุดนะครับใช้ซิมอย่างเดียวนะครับ 5G นะครับ alright and yeah when you put all the stuff here IBB right IBB into this expression okay because F1 and F2 are equal in magnitude as I told you okay but they are both are different in direction they have opposite directions to each other but they have the same both have the same magnitude and we can substitute it into this one okay, equation 47 and what you're going to get as I told you there will be factor 2 right when two things are added to each other you will have number 2 in front of that term and these two will cancel 1 by 2 okay that's the half of the moment side okay of that conductor 2 and 2 will cancel each other and you can see that AB okay the term AB and you can see that in rectangle right like this you have A and B here right and of course A times B is what you may have heard before in your primary school is the area okay area of rectangle okay and that's quite simple okay it's not difficult to understand okay AB is the area of the rectangle and that's why we are going to replace it okay by the capital A which is the area of your conductor okay and we don't go into the detail the length sides the width sides of the rectangle anymore okay we won't talk about it we will simply say or consider the area of that conductor only all right and yeah you can see that the expression become A I B sine theta อันนี้สำคัญนะครับพบได้เรื่องนี้ยาวครับโอเคไหมA I B or you can say is B I A sine theta it's up to you okay the way you will remember you can say I prefer this word E bar okay I B A sine theta it's up to you okay you may prefer A I B B I A IB is only the sequence of combination of these 3 variables okay but I will simply say BIA okay BIA BIA or sometimes you may say E bar it's better to understand or remember at your side okay it doesn't matter use any way any technique บางคนก็ไปเรียนพิเศษนะครับมานะครับเขาก็จะสอนบอกวิธีอย่างอื่นก็คุณก็เลือกเอาได้นะครับว่าคุณสนใจอันไหนนะครับเห็นไหมคุณอยากชอบสูตรใดนะครับคุณก็เอาอันนั้นมาแล้วกันครับ alright it's not too difficult BIA okay BIA BIA that's the way we we can use it to remember, but what is the reason why I prefer the word beer? Because after that, there is going to be an additional factor, which is the number of turns, okay, the number of loops, and that's the capital N. You will see that the formula changes to bien, okay, BIAN, bien later, okay, it will come later. Okay, on page 113, time is we still have 13 minutes. 113, you have BR, right? BIA and sine theta, and even the analysis is made from the rectangle shape of the conductor. But if you are at the bachelor degree, you know the technique of integration, you will find that this formula AIB, BIA, IBA, or any kind of what you want, okay? RB as well, all right? Another combination is RB. All right, all these are four forms of the formulas are valid for any shape of the conductor, okay? Not only rectangle. If you prefer your company to build up the electric motor by using triangle conductor, it's also possible. But the important thing is the area of your triangle. โอเคสมมุติใครจะไปเปิดบริษัทครับทำมอเตอร์นะครับอันนี้เป็นเรื่องทำงานได้นะครับโอเคไหมเปิดบริษัทได้นะครับเกี่ยวกับเรื่องการผลิตมอเตอร์คุณชอบขดลวดลงคุณเป็นสามเหลี่ยมเงี้ยก็ได้นะครับโอเคไหมเพียงแต่ว่าสิ่งที่สำคัญที่สุดนะครับก็คือ area นะโอเคไหมครับไม่สนว่าคุณจะเชฟอะไรก็ช่างขอให้เป็น area ก็คือคุณพัดขดลวดยังอะไรก็ได้นะครับให้มันมี area A มากที่สุดอะแล้วคุณจะได้ทอร์กมากที่สุดเพราะว่าอันนี้มันคือสมการของทอร์กโอเค it's the relation of the torque right so อันนี้นอกเรื่องนะครับขออนุญาตถามนิดนึงครับเตรียมไมค์คนไหนอยากตอบก็ได้ไม่ตอบก็ได้ไม่มีคะแนนอะไรครับอยากรู้ความคิดปีที่แล้วผมก็ถามครับ if we have the same length of conductor okay if we have a strong bendable okay the material that can be bent it's a strong made copper with the same length okay it's like 1 meter what is the shape that you can get maximal area from that conductor if you rotate it นะครับถ้าเรามีเส้นลวดยาว1 เมตร okay let's say we have 1 meter อันนี้นอกเรื่องนะผมถามคุณอันนี้ผมอาจจะไม่ตรงแบบโอเค if we have the long straight conductor like this and if you want to open your company อันนี้ถามในเซนส์ของวิศวกรwhat is the shape that we could get maximal area from the 1 meter cable like this ลองเปิดไมค์ถามนิดหนึ่งเปิดไมค์ตอบนิดหนึ่งมีคนไหนตอบได้ไหมครับ the first choice is for example circle okay circle the second choice is rectangle or sorry square A this is A this is B all right choice A choice B square okay there's no the third one is the choice C which is the rectangle what we have here rectangle all right and the fourth shape is it's I don't know it's triangle okay อันนี้ไม่ใช่ปัญหาชาวนะเป็นเซนส์ที่บอกว่าเราต้องการทอร์กมากที่สุดใช่ไหม the purpose of motor electric motor is to get better or maximal torque right okay what is the best is ellipse or oval right oval like this or any kind of shape what do you think then we could get maximal area มีคนไหนอยู่ไหมครับคนไหนตอบได้ไหมครับผมจะพยายามดู กิตติพันธ์อยู่ที่ YouTube โอเคครับเดี๋ยวผมครับเจอไหมลองคิดดูครับไม่ได้เตรียมมาสิผมมันไม่มีในสไลด์ครับเขียนมาผมลองถามคุณเฉยๆเล่นๆในเซนส์ของวิศวกรเพราะว่าวิศวกรก็คือคุณมีรีซอสที่ในแน่นอนครับในโลกนี้มันมีทรัพยากรธรรมชาติที่จำกัดคุณไม่สามารถมีเส้นลวดยาวเป็นอินฟินิตี้ได้แล้วคุณราคามันก็แพงเห็นไหมครับมันก็วิศวกรรมก็คือเป็นเรื่องราวระหว่างเศรษฐศาสตร์แล้วก็ science นะครับเอามาออกแบบผสมเพื่ออำนวยความสะดวกให้กับชีวิตมนุษย์ชีวิตประจำวันของมนุษย์นะครับก็อย่างถ่านหินอย่างเงี้ยเราไม่สามารถมีเป็นอนันต์นะเห็นไหมที่แม่เมาะอย่างเงี้ยครับก็มีจำกัดถ้าเราจะผลิตไฟฟ้าจะผลิตยังไงส่งกำลังไงให้มันเกิดประโยชน์มากที่สุดเช่นเดียวกันนะครับถ้าเรามีเส้นลวดยาว1 เมตรทุกคนมีเส้นลวดยาว1 เมตรในกรในขอนเลขที่1ถึงเลขที่24คุณว่าเชฟอะไรนะครับรูปทรงอะไรที่คุณเอาขดลวดมาพันแล้วเกิดพื้นที่มากที่สุดเพราะว่าถ้าเราได้พื้นที่มากที่สุดเราจะได้ทอร์กมากที่สุดเพราะว่าใช่ไหมเพราะ A เป็นแฟกเตอร์หนึ่งเป็นตัวแปรหนึ่งที่อยู่ในเบียร์ไซน์เธต้า What do you think please let me know หรือว่าพิมพ์มาก็ได้ครับใช่ไหมถ้าไม่เปิดไมค์ก็พิมพ์มาเดี๋ยวผม I try to see your answer in the chat okay I'm going to see your answer the chat is away my god in this because I get get lost in the internet connection and that's why I couldn't see but I think it's going to be saved in the text file right in the server according to the cloud มีคนไหนตอบได้ไหมครับตอบมาที่ไลฟ์กลุ่มก็ได้นะหรือว่าalright is there any idea about that มีใครตอบได้ไหมครับมีใครตอบได้ไหมอันไหนได้พื้นที่มากที่สุด What is that we need to talk about circumference right circumference of all those shapes โอเคอันนี้ไม่ใช่แค่สอนเรื่อง NCE alright you have to deal with this quantity which is what you may have seen already circumference of what of circle of square of rectangle of triangle oval any kind of shape okay you have the limit of using only 1 meter for the circumference to all those geometrical shapes okay and yeah which one is going to give you the maximal amount of area okay I will not give you the answer okay so that you can try yourself to get the answer or solution to this problem ไม่บอกนะครับเพราะว่าไม่มีเรียนในหนังสือฟิสิกส์ทั่วไปอันนี้ผมถามเล่นๆนะครับในเซนส์ทั่วไป okay let's move to the story that we need to accomplish in our lecture right it's it's be a sci-fi or sci-theta right it depends on the book okay I would not repeat it in figure 50 it's the results okay results from a different book but it's give you a lot of detail but it's in the same idea okay you have A and B okay they use B in the shorter side okay this is A in the former figure they use A to represent the long side of the rectangle okay but it's not complicated at all at the end you would get okay the moment is B by 2 and psi phi right it's not theta okay that's why I told you earlier please not be strict to only angle theta sometimes the books uses the variable phi okay to represent the angle between the normal vector okay this is the normal vector and the the magnetic direction here. Okay, magnetic is pointing upwards, and now the magnetic is pointing upward, and the copper wire is rotating, is tilted by angle phi. Okay, at the end, when you make the derivation, you will get again BIA psi phi. Okay, it's quite similar, 51 and 50. Okay, BIA psi theta. Okay, I forgot to mention this. What is the maximum value of BI psi theta? Okay, what angle we could get maximal torque from this setup? What do you think then? BI psi theta or E bar or RB, as you like. We would, in order to deliver the answer to you, okay, write down the nature of the psi function. Okay, psi starts from 0, right? Psi starts from 0 like this. Okay, and you will find that the maximum value will take place at the top of the mountain. Okay, when the angle here is 90 degrees. Okay, or sometime later, this is 360, right? 360, and here additional 90 degree. Okay, 360 plus 90 is going to be 550 degree later. Okay, it's 2 pi later. Okay, but anyway, the simplest or the shortest angle that we can get the maximum torque is going to be 90 degree, and that's why we get. Okay, this is the expression in mathematics in optimization in higher level, but don't worry about that. It reduces to sine 90 degree, which is number 1. Okay, it's quite simple. Only BR. Okay, E bar or RB, up to you. Okay, BR. And again, BR psi phi will give you the maximum amount, which is BR without psi phi. Okay, it's number 1. And yeah, the torque is maximum when the angle between the normal vector and the magnetic direction is 90 degrees like this. All right, direction normal to the loop. That's the normal vector as I told you, this one. Okay, and yeah, the maximum torque is gonna happen at 90 degree BR. Right, and what is the lowest amount of the torque that can happen? Okay, I have to leave the class right now. The torque will be minimal. Okay, the minimal amount will be at the minimum when we have 0. Okay, according to the nature of the psi, as I told you, it starts from 0 and reduce 0. Okay, right. This is the max, the point where you get the lowest value of the psi. Okay, that's the phi or theta is at 0 degree, right? And now we arrive at torque. Okay, at the lowest position, which is 0 degree, equals 0. There is no torque at all. Okay, there is no problem. There is no homework for the today lectures. See you on Friday. If you have any questions, just let me know. If not, then we're gonna leave our lecture right now. สวัสดีครับ บ๊ายบายครับ พบกันวันศุกร์ครับ
บายครับอาจารย์บายครับบ๊ายบายครับ
บ๊ายบายครับ
ฝันดีครับฝันดีครับ
สวัสดีครับ Stop. Oh no, we have to quit the lecture, right? Okay. Then